Are we live? I think we're live.
I think we're
Yeah.
live.
Welcome today to the Service Mesh Academy. We are going to be talking about Service Mesh extension, and we're going to say Service Mesh a lot. Um, so,
Yes, yes, we will.
yeah. Quick introduction. My name is Andrew Gracie. I am a product manager at SUSE. I helped work on some of the ideation and a little bit of the technical pieces on how to build out this feature. And Flynn, who most
Andrew had
everybody
the
here probably knows.
Andrew had the privilege of, I think privilege is the right word, of
Yeah, honestly, this was
helping with one
really,
of the
really fun.
very, very early demos of how to do this the extremely hard way. So this
Hey,
is the easy way, thankfully. Yeah, I'm
shoestring and
Flynn.
baling wire.
Yeah, I'm Flynn. I'm a tech evangelist with Buoyant. I deal mostly with the open source side of Linkerd, and yeah, probably people are familiar with who I am. Um, I guess we should go ahead and fire up the screen share and get started, huh? All
Yes.
right. Oh my God, that seemed to work. That's amazing. Yeah, we're going to talk about mesh expansion the easy way since we've talked about doing it the hard way several times by now. Um, but first, a note from our sponsors. We have a Linkerd book out, Linkerd up and running. You should go check it out. I wrote it with Jason Morgan. We hope it's good. If it's not good, you should let us know what you think so we can make it better. We also have another ebook out there that has been around for a little bit, but is still proving really useful. The Kube Crash ebook about the zero trust reference architecture that we put together with lots of other people. It's good stuff. You should also check that one out. And that brings us to the agenda for today. We will be doing a pretty quick discussion of what we mean by mesh expansion, and then we will be rolling into a demo. So everybody should pray to the demo gods. Um, this is another one where, well, I think the sources are correctly up in the repo right now. It's the same 215 mesh expansion directory that people have seen before. This one is a little bit interesting because as we're doing this the easy way, we're taking advantage of the auto registration harness that is present in Bell Preview 24.5.3 or 2.15.3 when that comes out shortly. This will require you to go and get a Buoyant ID from enterprise.buoyant.io. I promise you, we're not going to go and sell your information and send you viruses and horrible things like that. Really, I promise it'll be okay. Um, and on that note, let's talk a little bit about this whole mesh expansion thing. The concept is really simple anyway. We're going to arrange it so that you can take workloads that are not in Kubernetes and allow them to still participate in the Linkerd mesh. We first supported this in Enterprise 2.15.0 or Edge 24.2.4 over on the open source side of the world. It's literally what it sounds like. You take a cluster, and instead of having all your workloads inside the cluster, you want to set it up so that some of them are not inside the cluster, and instead some of them are just randomly running on Linux boxes. And that's kind of all, from a very high level, that's all there is to it. Reasons you might want to do this. Actually, Andrew, you might be in a better position to talk about this than I am. But
Yeah. So
yeah,
this
go ahead.
idea really came from several customers that I was talking with at the time, where they were. So full transparency, it really came from a lot of customers asking, like, okay, how do we scale K3s down to like run on a node that has like a gig of RAM, right? And I'm like, why? Why do you really want that? Well, it's because they want to be able to treat all of their infrastructure effectively the same way, which I think is a pretty valid reason.
Makes sense.
And so one of the pieces that we realized pretty quickly that we were going to need was for workloads that are on those really tiny nodes to be able to feel like they're actually a part of the cluster. I'd been using Linkerd for a little while at that point and went, oh, I think putting this in the service mesh could make a lot of sense so that your developer experience is the same as any other application that's running in your cluster. The operator experience might look a little different, but we can we
Yeah, but
can um,
we
we
can
can
deal with
build
that.
additional
Yeah.
tooling to improve that piece.
But the architecture
And
that kind of kicked it all off is this idea that you've got a bunch of random little instruments with some local
yeah,
compute that are talking to something, usually a
yeah,
Kubernetes cluster.
industrial IoT gateways,
Yeah.
yeah, embedded devices, kind of whatever you need.
And we also have this interesting characteristic that the communication from the device to its local processing is going to be safe because it's like a serial port or a USB connection. But the connection from the local processing into the cluster is problematic because that's, just running over an Ethernet or Wi-Fi or something like that. And Andrew, I think you were telling me at one point that a depressing amount of the time, those are not secured in any particular way. That as you see things.
Yeah, there's a lot of historical reasons for that. OT and IT have grown up in separate different worlds, and there's a lot of good things that OT does. There's also a lot of things that OT could learn from IT, and vice versa. So, yeah,
Yeah. So we really want those connections to be safe, and the easy way to do that is with MTLS. And the easy way to do MTLS, like Andrew was talking about, is to throw Linkerd into the middle of it. I just love it when my browser pops up a "Please update me" thing while I'm doing a live demo.
right in the middle. Yep,
Yeah,
that's how it goes. Better
thanks.
than
Appreciate
Windows
that,
just
browser.
restarting.
That's awesome. Oh yeah, yeah. Better than restarting. So this is the idea: is arrange things so that we can get to a world like this one. Um, there are a couple of benefits to this one. We were just talking about access to smaller devices, like, tiny little edge nodes. I've actually demoed this a fair amount of the time on Raspberry Pis, which is pretty cool. It also gives you access to legacy workloads where you've got some huge thing running outside that is difficult or impossible to bring into the cluster. This is a way of safely getting communications to that thing. The implementation part of this is kind of straightforward to talk about anyway. You basically just run the Linkerd proxy next to your external workload. What could be easier? The answer turns out to be lots of things. There are a number of challenges that come along with this one. Trust in the whole shared system is a little bit interesting. The network and DNS, it's always DNS. All of these things get to be a little bit interesting, and we're going to talk about all of them, going forward. One thing that I am going to take a moment to mention right now, though, is that ultimately we are still relying on the Linkerd trust anchor to be the root of trust in this whole wide system. But it's also worth pointing out that inside the cluster, we can rely on Kubernetes service accounts, and outside the cluster, we don't have those. So outside the cluster, we rely on Spiffy, and we will talk about how we set things up there. So, yes, the DNS haiku. Yes, indeed.
That was appropriate.
Yeah. Run the Linkerd proxy, like I was saying, is not really that easy a thing. We've gone into this in a lot of detail in some of the earlier SMAs where we talk about doing this the hard way. In this one, we're going to do it the easy way using Bell's auto registration harness. And the way this works is that if you remember from the earlier SMAs, we would create this thing called an external workload, but Bell introduces the external group resource. Then your workload, we actually provide a Linux package. We do this in Debian or RPM formats right now. You install that. That brings the things that you need in on your Linux box. When you run it, it will talk to the auto registration controller in the cluster and tell it, hey, I want to be a part of this external group. And here's my IP address and things like that. And then the auto registration controller manages creating external workloads, making sure that things are healthy, removing endpoints when they are not healthy, adding them back in when they become healthy again. And the end result is that you get something that's very parallel to deployment and pod, where in a normal cluster, you create a deployment, and then there's a controller that hides away in the background watching. It will go through, it will create pods, it will go through and manage taking the pods IP addresses and putting them into endpoint slices that services can then reference and all that. We're doing exactly the same thing. We can't actually use deployments for this because the deployment controller assumes that you are always doing things inside Kubernetes. So we had to create our own controllers that could look at external groups and then create external workloads for you. And I realize that we're kind of glossing over some of this quickly. I am hoping that this will be a little bit more clear as we go through the demo, but if it is not, this is a great thing to ask more questions about. On that note, Andrew, do you have any questions?
So many relevant to this. No, I think this is pretty clear for the moment.
So far. All right. In that case, everybody cross your fingers. It's demo time. The specific way I'm going to be doing this demo right now is we're going to walk through this whole thing where we're going to run a K3D cluster on my laptop. We will fire up a bunch of Docker containers running in the same network as the K3D thing to be our external workloads. And then we're going to go walk through the dynamics of how all this stuff plays out. So off we go. Except that it would be helpful if I had hit return in the right window. So we'll come back to this IPv6 thing. All right, we're going to start getting K3D running. Most of this is fairly straightforward if you're used to K3D. The two things in here that are possibly kind of not terribly straightforward are, first, that I am explicitly telling it the name of the network I want it to be attached to so that I can attach other containers to that network. And I do not need traffic and I don't need the metric server. So I'm going to turn those off because it means the cluster comes up faster. It works fine if I leave them. I just don't want to wait because I'm impatient, especially when I'm doing a demo. All right. The next thing we would do normally is to install the Linkerd CLI. Normally, this would happen by running this command. Don't tell anybody, but right now, if you run this command, it will give you preview 24.5.2, even though it should give you 24.5.3. And so this is commented out at the moment so that it doesn't accidentally down rev my Linkerd client. But with any luck, by the time this is done, then the proper hamsters will be kicked into gear or something to make that do the right thing. But anyway, we have preview 24.5.3 here. I have also already gone to enterprise.buoyant.io. I have gotten my Buoyant ID. I have set the Buoyant license environment variable, which is what it tells you to do. And that is a very important part of this, because if you run the commands I'm about to run and you don't have Buoyant license set, then it will come back and give you an error saying, no, you need to go set up your license. So we will install Linkerd CRDs. Fun note is you can see here external groups and external workloads. Very nice. And then the next thing we're going to do is we're going to install Linkerd itself. Now, you will note that I am explicitly telling it what certificates I want it to use. I created these certificates yesterday. And the reason we need to tell it explicitly which certificates to use rather than letting it go and do its own thing is that when we start up Spiffy, or rather when we start up Spire, the Spire server, you know what? Let's back up a second and talk a little bit about Spiffy and Spire. Spiffy is a standard for talking about identity in a very network-centric, hopefully safe kind of way. Andrew, do you have a better definition of Spiffy you like to use? It's actually an acronym for something, but I don't remember what it stands for.
I don't remember what the acronym is either. No, because it's confusing and complicated, and that solves a lot of problems.
Yeah, there's a challenge with identity, which is that at any given layer, you need something to basically attest to the world that the identity you're slinging around is valid. And this is historically a difficult problem to solve. The Spiffy guys solved it in a way that is viable. It works. It can be pretty complex, but it works. And there are a couple of important things to say about this one. The first one is that the way this happens mechanically is that you have your workload, Then you run a Spire agent next to it. Spire is the Spiffy runtime environment. You run a Spire agent next to it. The workload then talks over something like a Unix domain socket to the Spire agent. The Spire agent figures out whether it can trust the workload talking to it, and then it goes off to a Spire server to say, hey, everything is legit. Please give me the appropriate identity material, which is an X509 cert for this identity. In order for...
I just got pinged from somebody at SUSE who gave me what the acronym means. So
Oh, what's it mean?
Security Production Identity Framework for Everyone.
Excellent. And props to whichever of your
Yeah.
coworkers is watching the show.
Thank you, Alex.
So in Linkerd land, the identities that come back from the Spire server have to be signed ultimately by the trust anchor. Or if we want to really be technically about it, the trust anchor has to be somewhere in the chain of trust, et cetera, et cetera. We can talk about that in a more complex way. We, for purposes of this demo, are going to cheat massively. We are going to run Spire servers on all of our external workloads, and we will just mount these certificates into the Docker containers so that the Spire servers we run have direct access to them. Don't do this at home. This is well, okay, you can do it at home. Don't do this in production. It's a terrible idea for production. But, this is a demo about mesh expansion. This is not a demo about proper Spire attestation. So that is why we have explicitly created certificates. We're explicitly telling Linkerd which certs to use. It's so that we can then take the same set of certificates and hand them to our Spire servers so that the right thing happens. Every time I do this demo, I say, and soon we're going to do a demo about how to set Spire up in a reasonable way. And I'm really looking forward to being able to do that. And I have not had bandwidth to set it up yet, which is really, really frustrating. But on that note, at the security conference in September in Seattle, Dave Sudia of Teleport will be talking about Linkerd and Teleport and Spiffy and Spire and all that good stuff. And I don't think I'm going to be able to join him, which makes me really, really sad. He'll do great.
I don't think I will either.
It just makes me. It just makes. Yeah, I mean, he'll do great. It just makes me sad that I don't think I'm going to be able to be there. All right, so now we've got Linkerd running. I totally glossed over the part where we ran Linkerd check to make sure that everything is running. Sorry about that. But you know what? I can do it again. Ta-da! All right. Now, what we were about to do here, before I so rudely interrupted my demo, was we're going to install the Faces demo into this cluster, which we're going to do for starters. We're going to create a namespace for Faces. That is done. Then we're going to annotate it with Linkerd.io inject enabled so that everything gets automatically injected. And then we will use Helm to install the Faces demo. There are a couple of things about this that are a little different. I'm not actually using an Ingress controller for this. So I'm just telling it, hey, Faces GUI, be on a load balancer. I can get away with this because the Faces GUI has some poor man Ingress controller logic built into it. Again, not a great idea in production, but it really simplifies talking about this demo. So that's why I do it. Also, I am setting the error fraction to 0 because, again, this is not a demo about how to debug Faces. So I'm just going to tell Faces to be well-behaved. It feels really weird to have a well-behaved Faces demo, I should probably point out. So there you go. We've got face and smiley and color and the GUI all running, 2 pods each, one of which is the application and one of which is the Linkerd proxy. And if we flip over to the GUI, there we go. We've got grinning faces on blue backgrounds and everything is happy. This is what we like to see. Now, that is also not very interesting because that's just running in my Kubernetes cluster, and we can run Faces inside a Kubernetes cluster pretty much anytime we want to. So let's just break this, shall we? We shall delete the deployment for the face workload and the deployment for the smiley workload. We're going to leave the services in place and just smite the deployments. And if we flip back over now, nothing is working. The GUI is trying to talk to the face workload. it is getting an endpoint because the service is still there, but nothing is talking to it. So, all right. What we want to do is run the face workload outside the cluster. So here's the list of things that have to happen in order to be able to do this. Number one, our external workload, which in this case is going to be a Docker container, it needs to be somewhere where it has direct IP address access both to the pod and service IPs in the cluster. It needs both of these because if one of your workloads talks to another workload, it's going to do a DNS lookup, which is also on this list. In fact, it's number 2. The external workload needs to have access to the Kubernetes DNS because workloads, if they try to do something like our face workload, trying to call Smiley, it's going to look up and it will do a DNS lookup to try to find Smiley's IP address. When it finds it, it will get an IP address in the service IP range, but then Linkerd will route to pods in the pod IP range. When we first start everything running, though, the harness running in the external workload has to talk to the Linkerd control plane. It will also use an IP address lookup for that, and there it will be talking to a service, the service itself. So, got to have direct IP access, got to have access to the DNS. The external workload needs a SPIFFE identity, which we mentioned. This doesn't say it explicitly, but I'll add on to this that the certificate that it gets back from SPIFFE must be signed by the trust anchor. Our external workload needs to have the Linkerd proxy next to it, which implies also that there needs to be bunches of madness going on with IP tables. And new for Bell and the auto registration harness, we have to create an external group in the cluster so that when our external workload goes back through the auto registration controller and says, hey, this is the external group I'd like to join, there's something there for it to join. All right, so let's get going.
And that list is already so much simpler than it was.
Isn't it though, just?
Right?
I mean, even given that this is the high level list and I'm going to have to go into some details, it's so much simpler. Kenneth asks, which security event in Seattle? I am going to remind me at the end if I don't get to it, and I'll put the info about that. All right, so let's get going. We're going to start with routing. So I'm going to run Docker containers. I'm going to explicitly tell them to join the same network that the K3D cluster is in, but that is not enough for them to be able to route directly to pod IPs or service IPs. For that, I need to actually run IP route add commands, and that means I need to know what to route via. Turns out that the node IP address is a great way to do that, so let me grab that. That's my node IP address. I can get the pod CIDR out of Kubernetes, which is great. 10.42.0.0/24. For some crazy reason, Kubernetes won't let you read back the service CIDR. If you're running K3D, chances are really, really good that your service CIDR will be 10.43/16. But if you're, depending on how your cluster is set up, you might need to change this if you're trying to follow along at home later. I don't know why Kubernetes won't let you
really
read that back. It's kind of weird. So given that, we will be able to run IP route add commands and everything will be great. Next up, DNS. Kubernetes runs a DNS server, which is great. The kind of less great part of this is that by default, it's running with a cluster IP completely inaccessible from anything outside the cluster. And we're going to change that to make it accessible outside the cluster because that's a fairly easy way for us to deal with this. First things we're going to do is we're going to switch kubedns to be on a node port, specifically on port 30,000. And then we're going to run a separate Docker container that just runs DNS mask to forward anything for .service.cluster.local over to that DNS server running on port 30,000. Why, you may ask? Do we need a separate DNS mask container for this? It's because basically no application out there is comfortable using a non-standard port for DNS for various reasons, which are mostly really, really good. Thankfully, DNS mask can do that for us. So we're just using DNS mask as a way to handle port mapping, really. Also, it's limiting us to the service IP address range. So, that's marginally more secure.
Yeah, I think for actual production use, I would probably put all of this in, all of everything in its own VPN, right? So that way you
Yeah.
don't have to worry about like opening up your DNS to the public.
The other thing that you could do that I've thought about doing a lot is you could run a separate instance of core DNS, right? Rather than abusing the main cluster DNS server, you could just run a separate instance and then you have explicit control over what you want to put in
True.
so that you
Yeah.
could do things like, oh, when I create my external group, I will say it's okay to access that particular name as opposed to all the services in your cluster. Could be worth doing. All of that, I think, is going to get to be much more relevant when Linkerd gains the ability to do this without direct IP address or
Mm-hmm.
direct IP access. Then I think that'll get to be much more interesting. All right, so here we go. I've changed it to a node port. I've explicitly said which node port I want it on. I'm going to write that out. And if I then look at the service, we can see, hey, look, it shows up on port 30,000 now. Isn't that awesome? Now, Dr. Seichik has helpfully made a DNS mask image that we can run. It wants to do a lot more than what I want it to do. So I'm going to thoroughly abuse Docker run. I'm going to volume mount a custom script and then tell it that my volume mounted custom script is the entry point. I'm not going to lie. When I first did that, I wasn't even sure it was going to work, but it does. So here's my custom script. It requires a DNS host environment variable, and it literally runs DNS mask and tells it to do absolutely nothing except forward service.cluster.local to port 30,000 on the DNS host. That's all. And then it just goes into a sleep loop. So here's the first of many Docker run commands that will look pretty weird, or at least maybe a little bit non-standard might be a better way to put it. --detach --rm. Run this in the background, and when it dies, get rid of it. Cap add netted men. We have to have that so we can bind on port 53 for DNS mask. Net meshexp tells it, be on the same network as the Kubernetes cluster, please. Here's the volume mount for my forwarder script. I'm going to enter on sh and pass sh-c with this thing. I had to do that because it's very difficult to get permissions to work out otherwise. Or maybe a better way to put it is I didn't want to go to the effort of getting permissions to work out otherwise. This is setting our environment variable that you saw in the DNS forwarder script. We're going to call this DNS mask, and then we're going to run the Dr. Seichik DNS mask image. And now we can use Docker inspect to find out the IP address of our DNS server. Ta-da! Okay, so now we have a running DNS server. Isn't that exciting? Next up, Spire and Spiffy, or Spiffy and Spire. Let me highlight a thing in this demo. This is a terrible idea in the real world. Don't do this. But this is a demo, so, whatever. So,
and somebody's going to. Myself included.
You're not going to run this in. I trust you not to run this in production, Andrew. Don't disillusion me. At least not before tomorrow. I am going to show you the Bootstrap Spire script, especially because this might be useful for folks in other environments, or at least part of it might be useful for folks in other environments. This is going to look a whole lot uglier than the one you remember from the hard way, and the reason for that is I learned a few things about how to make this come up much more reliably and faster and things like that. So let's take a look at it. All right. We require an environment variable Spiffy ID to be set. That tells us the ID that we expect to be generating from this thing. Next up, we run the Spire server. We hand over this server.config. I'm actually not going to walk through server.config. It basically just tells it, bind to a port on localhost and I think it tells it things like use SQLite or something like that. It's, you can take a look at it in the repo. It's not very profound. Next up, here's what we want. We want this thing to generate a token that an agent using this Spiffy ID can use to prove when it talks to our Spire server that it's okay for us to listen to it. And what we do here is we use Spire server token generate to get the token, and we're going to do this in a loop just to make sure that the Spire server has enough time to get started and we get a real token. I'm not going to lie, I haven't actually seen this part take more than, I think I might have seen it once, but usually this just runs the first time and it's great. Next up, here we're going to tell our Spire server to generate our Spiffy ID for us. Its parent is going to be this agent ID, and this Spiffy ID belongs to people that talk to us claiming to be the Unix UID that goes with a user named proxy harness. The proxy harness user is installed when you install the Linkerd package that carries all of the goodness of the auto registration harness into your external workload. So that's where that comes from. And then after we do that, we start the Spire agent. We tell it the token that we got up here so that our server knows it can trust it. And then finally, we run this. We're explicitly saying, run this as the proxy harness user, and then try to fetch your ID from the Spire agent. And until it can do that, we just sit there and wait. Because if you try to have things come up before there's a Spiffy ID ready for it, the harness does not like that. And the Linkerd proxy does not like that. And, there's no point in putting it in that situation. All right.
So have we looked at using like a hardware root of trust as part of this as well?
We have not yet. You want to know
Okay.
why? The reason we haven't looked at that yet is that I can't get any TPMs for my Raspberry Pis.
Oh, I'll ship you some.
Oh, okay. Well, that would be cool. The whole supply chain thing is really maddening right now.
Agreed.
In related news, if anybody in the workshop channel happens to know a really, really good US-based PCB fab house that can source parts for you, let me know. Because I'm kind of getting the nasty feeling that JLC PCB and the other Chinese fab houses, I don't think they're going to be able to get things like TPM chips. It's really, really annoying. Kenneth just says, YubiKey with PKCS 11. Ooh, that would be very cool. And oh man.
Like that.
Well, I don't want to stop right now and try to figure out how to get this to work. But yeah,
We'll do
that would be
another
cool.
Service Mesh Academy with that.
Yeah, it'd be kind of cool, wouldn't it? All right, so there's how to bootstrap Spire. The last thing we need is we have to get the Linkerd proxy running. Now, going through and talking about how you do this the hard way is several pages of text talking about all of the stuff we have to do and showing off the script that sets up IP tables and doing all this stuff. And oh my God, the auto registration harness is so much nicer here. Here's the way it works with the auto registration harness. You go over to your workload and you install the harness. I'm going to use the RPM package because I'm doing this all with OpenSUSE and the Docker containers. That creates the proxy harness user that installs things like the proxy and some initialization scripts, and it fires up a systemd resource, a systemd unit, I should be saying, so that you can literally do system control start Linkerd proxy harness. And it's a thing of beauty. So instead of having pages and pages and pages of text about how to set all this stuff up, I can just say, install the package, use systemd.
It's that easy.
There we go. If you don't want to use systemd, and there are reasons you might not want to, particularly if you are containerizing the whole thing. This turns into 2 lines instead of 1 line. It's really not that bad. And we can talk about that after the fact if you like. Important note, you do have to have the external group resource created before you try to start the harness on the workload. Because remember, the first thing it's going to do is it's going to go back and try to join one. Actually, I should phrase that differently. You should create the external group beforehand. I'm actually pretty convinced at this point that if you don't, then it can still find it when you do create it, but just create it beforehand. It's nicer. All right. Question so far? Anybody?
I don't see any.
Okay. I suppose I can check over and yeah, I'm not seeing anything in the SMA chat either. All right, cool. Oh, you know what I've been forgetting to do? I've been forgetting to put up things like this. That's the URL for the GitHub repo that I'm working out of here. Just, FYI. All right. Onward. You'll recall I said that we were doing this with Docker. And I'm not going to lie, I tend to use containerized stuff even when I'm running this on my Raspberry Pis, because it's a really nice way to sort of limit the scope of all the IP tables madness instead of like having the proxy take over all the networking stack of my whole Raspberry Pi and then confuse the world. Not that I've had that happen, you understand. So there is out there a pre-built image, ghcr.io/buoyantio/demo bell workload 1.2.4. It has the faces workload in it, but much more importantly, it also contains the RPM package. I think it contains the Debian package too, come to think of it, for the harness. And it contains the bootstrap scripts that I've been talking about so far. So this is a convenient way if you want to run faces as an external workload for your own demo stuff. This is the bootstrap that it runs. Let me go ahead and turn this off so that it's easier to read. I'm going to call everybody's attention to this again. Do not run this in production. But it's a lot simpler now, right? Go and install the proxy harness. I am optimistic that the no deps bit will go away by the time this ceases to be a preview, but right now I need it because it wants a dependency for a thing that turns out to not exist. So gotta sort some of that out. It needs sudo and it needs gettext, just FYI. We need the workload name and the workload namespace to be set because we're going to hand that over to the harness in a minute. And we also need the certificates that Spire wants, which I think is actually set in the Spire or checked in the Spire bootstrap as well. So I should deal with that. All right. Oh, somebody posted a service cider trick. All right, yeah. I'm gonna go take a look at that. Okay, so once all that is done, we set our spiffy ID environment variable, which Bootstrap Spire needs. We run Bootstrap Spire, that's synchronous, that'll block the Bootstrap for the whole thing until Spire is up and ready to go. If you set Node IP and Pod Cider and Service Cider, it will do the IP route adds for you. The reason that this is a conditional is that in some cases you won't need to do it. And then we have our magic harness control command, where this subsumes so much stuff that we had to do the hard way. Here's my workload name. Here's my workload namespace. Both of those are used as, this is the name and the namespace of the external group you want to join. These are basically boilerplate for how you talk to the Linkerd control plane. Honestly, I kind of wonder if we'll just end up allowing those to be defaults later. And then we start the harness and start the workload.
Yeah, and I think probably the enhancement that I will look to make in the future is actually running a lot of the setup piece in. So Podman gives you the ability to actually run pods, right, and have like effectively init containers if you want. Yeah. And they share the same C group and network namespace and all that. So you can even better encapsulate,
better isolate things.
Yeah, exactly.
Yeah, I've been playing more with Podman on the Pies and realizing that a lot of the ways that I was using it are remarkably primitive, I think is a good way to phrase it. And so I look forward to collaborating some more on that
Probably
too. That'll be pretty
always
cool.
true. It does so much.
It's pretty cool. All right, so that's the Bootstrap. That is the thing that's cool about this is that this is, it doesn't matter what the workload is. That's the way you would set it up to work as an external workload with the proxy, right? Okay, so it's time to actually start some stuff. Remember, this whole time, we've been sitting here where my GUI is showing me sad faces on a purple background because it can't talk to anything at all. So let's go ahead and get that actually fixed. Here's the external group I'm going to supply. Its name is face. Its namespace is faces. We get to define probes. So what's happening here is that the controller is going to go through and constantly try to talk to my external workloads. When an external workload shows up and says, hey, I'm here, then the auto registration controller is going to start probing it to find out whether or not it's really valid. And assuming that it is, it will go through and allow traffic to proceed to that thing. Again, very much parallel with the way deployments and pods work, right? You don't actually start feeding traffic to a pod until the pod is ready. We also have this thing where this should be, fairly familiar. But what's going on here is, again, like a deployment, as we create external workloads from this group, they will all get the service face label, which is not coincidentally exactly what the face service is trying to match on. So our service will collect all of these endpoints. And we also need to tell it, of course, what ports are live. So let's go ahead and install that. Absolutely nothing will happen at this point. If I flip back over, it's still dead because we haven't started any external workloads running yet. All right. This is also an ugly looking Docker run command. It's not actually as bad as it looks, I promise. Same things we saw before, right? Run it in the background, get rid of it after it dies, be netadmin so we can mess with IP tables, attach to the mesh expansion network. Remember, we got the DNS, the IP of our DNS container. So we'll tell it, this is the thing you should use for your DNS server. We're going to give this thing a name of face1. We're also going to explicitly set its host name. And the reason for that is that in the GUI, we can ask to see the pod names for the face workloads that we're getting back. And it expects them to kind of look like Kubernetes pod names with 3 parts. So I'm giving it one that has 3 parts. Mount asserts, like before, we just saw we need to know the workload group we're going to join. We're going to go ahead and set PodCyber service CIDR and node IP so that our container, the Bootstrap script, can magically do IP routing for us. And then these are variables that our actual face workload wants. We want this to be the face service, and we're also going to explicitly tell it to use FQDNs when it tries to talk to Smiley and Color, because even though if you're running face as a deployment, then it knows it's in the faces namespace and it knows how to do the right thing with DNS. When we are running it outside, it does not necessarily know how to do that. So we'll tell it to use fully qualified domain names to talk to Smiley and Color. All right. This is the point where everybody should really cross their fingers. So let's see what happens. This is one of those, there we go. So the endpoint controller found that an external workload had attached. You'll see a short little bit after that, it found, oh, hey, the probe succeeded, an endpoint comes up. Life is great. And you can also see that the display has changed. Now we're getting cursing faces on blue backgrounds, which means that we can talk to the face workload, but face can't talk to Smiley. It can talk to Color. That's because Color is running in our cluster and Smiley isn't running anywhere at all right now. So onward. Same thing. We're going to make an external group for Smiley. This looks pretty much exactly like the one for face, except that it says smiley instead of face. So we'll do that. And then we're going to do basically exactly the same thing, except that again, we've changed a bunch of instances of the words face to the word smiley so that we get to run our smiley workload off the cluster. You'll also note that there are kind of fewer. Sorry, we don't actually need that node name environment variable. That's left over from an earlier rev. Oops. You'll also notice that we don't have to set the smiley service and color service on this one because the smiley workload doesn't talk to any of that stuff. So let's fire that up. And again, we're going to watch the external workloads, and we're also looking at Linkerd diagnostic endpoints, smiley.faces.service.cluster local. And there we go. So let's take a minute here. What we have happening here is that in our Kubernetes cluster, we have services named face and smiley, both of which are pointing outside the cluster to external workloads. The external face workload, in turn, is calling back into the cluster for smiley and color. The color request is being handled by a workload that is actually in the cluster, but the smiley request is being handled by one outside the cluster on a different Docker container. And all of this is happening with MTLS and all that good stuff under the hood. Also not seeing any other questions so far. So one kind of interesting thing about this too is that external workloads end up defining endpoint slices. So you can actually look at these with a bunch of kind of normal Kubernetes sorts of tools. An interesting thing here is you will see, we'll pick on smiley for a minute. So there's this endpoint slice here called smiley dash something. And then there's another one called Linkerd external smiley dash something. This one is being created by the normal Kubernetes endpoint slice controller, which only knows how to look for pods. So it finds no endpoints. But this one is being created by the Linkerd endpoint controller. Sorry, the Linkerd endpoint slices controller. Say that 3 times fast. It knows how to look for external workloads, and so it finds the IP address of our external workload.
So does that mean that it would potentially even work with like Gateway API?
Hold that thought.
Okay, cool.
But one thing that is pretty cool about this is that bringing this kind of full circle, the reason that our smiley service is able to work with this is not that Linkerd is doing anything particularly funky. It's that services know how to look at endpoint slices that have the right labels on them. Very cool. All right. Now, suppose we want to do something more interesting. The first more interesting thing we can do is we could fire up a second external workload for face. Just like we could fire up an additional, we could scale our deployment to multiple replicas, right? So in this case, we're running basically the same thing. We are changing the name to be face2 so that we can find it in Docker, and we're changing its host name to have an x2 on the end instead of an x1 on the end. But other than that, the rest of this configuration is exactly the way we did the Docker run for face in the first place. When I get to talk about this faster than the typing finishes, man. All right, so let's get that going. And now we'll get the same thing going here.
I know. Imagine trying to actually type that during a demo.
That would be awful. So here's our new endpoint that just showed up, or sorry, our new external workload that just showed up, and our new endpoint that just showed up. And if we come over here and I find my window, if I click show pods, you can see face x1 and face x2 are both happening. So Linkerd is just seamlessly allowing load balancing to happen here because of the way this all works, which is pretty cool. Shall we live dangerously?
I mean, yeah.
Oops, you can't see the dangerous thing I did. I just killed face 1. And then if I come back over here, you will see that face 1 is now gone. In a little while, eventually that face X1 will fade away and we'll just see from face X2. But once again, this is kind of the moral equivalent of just randomly killing a pod out from under it and the rest of the system works fine. If I come back over here, we can see that there's only one endpoint there now. And if we come back over here, you can see that face X1 eventually vanished just because the GUI lets that take a little while. We can also see, just for the fun of it, you can tell that I'm the one who's really typing right now because it's so much slower, right? You'll notice that there's only one external workload for face now because there's only one. All right. So if we come back here, like I said, Linkerd was just transparently enabling load balancing there. And really, as we've mentioned a couple of times, this is just kind of slotting into the existing narrative around deployments and services and pods, where we're letting external groups take the place of deployments and external workloads take the place of pods, and everything just works because that's the magic of Kubernetes or something like that. The magic of Kubernetes with a whole lot more work underneath it, right? So that brings up an interesting question. Suppose we fire up an external group for color. And again, the only thing I'm changing here is the, what goes in the label and the name of the thing. If we fire this up, but we don't get rid of the existing deployment first, I'm actually not going to wait for it to type all of that. I'm just going to tell it to go ahead. Here again, the name is changed. We're changing that. We're changing the service, and we're also going to explicitly tell this one that we want it to be the color green rather than blue. So if we fire that up and then come over here, then what should happen is that shortly we should see a color external workload show up and a color endpoint, hopefully. And you can also see that, well, this probably kind of should be about a 50-50 split, but load balancing, especially because this is a fairly low traffic rate here. This is only like 8 requests per second. So we're not going to really see exactly a 50-50 split, but this isn't bad. But again, go into the cluster to talk to the service, and then it's getting split between a workload in the cluster and a workload out of the cluster. And if we toss the external deployment now, then you can already see that it just all went green, right? And we can see that we still have the external workload for color, and now the only endpoint is the one that's no longer in the cluster. At this point, by the way, just as a random point of interest, our cluster is doing absolutely nothing except serving as a rendezvous point. All of the workloads are running outside of the cluster, which was a funny thing to realize while I was putting this together. And getting back to Andrew's question about, oh, hey, maybe you could make this work with Gateway API. Well, yeah, we can do that. Suppose we create a new service called Smiley2, and we create an external group for Smiley2. So we can go ahead and apply those things. And now I'm going to run an external workload for Smiley2 as well. And again, I'm just going to skip to the end. Name is Smiley2, Smiley2, Smiley2. It is still using the smiley faces service, but this one is doing hard-eyed smileys instead of grinning smileys. So we can start that going, and in a minute we will see our usual external workloads and endpoints show up. There's our external workload. There's our endpoint. This is kind of our usual stuff. And if we bring up the browser now, we will see absolutely nothing different, because all I've done now is just bring up the moral equivalent of a deployment and a service, but it's not taken any traffic yet. We can fix that with an HTTP route, to Andrew's point. So this is saying anything going to the Smiley service in the faces namespace 80% of it will go on to Smiley, but 20% of it will go to Smiley 2, despite the fact that Smiley 2 isn't even running in the cluster. But that's okay, because Smiley is not running in the cluster either anymore. So if we apply that, we start seeing some hard-eyed smileys show up. If we go through and edit the canary weights on this, then we can immediately see differences. Yeah, there we go. One of the fun ones that I like to show off with this one is that we can actually do a 0-100 split with that as well. And so now we get all hard-eyed smileys. And just for the fun of it, the only thing running in the cluster in the faces namespace is the pod that serves the GUI, which is doing absolutely nothing because we already served the GUI. Everything else is all being handled by external workloads and external groups. Worth noting, there is an enormous amount we could do here that we're not doing. Like we haven't actually looked at author observability at all, which we will have to do another day. But this is all sort of an introduction to how to do this the easy way. If you have seen it the hard way, this is so much easier. Oh my God, it's great. And yeah. Andrew, do you have any questions while we're doing this? Otherwise, I can live a little dangerously as well and see if I can make anything happen on Raspberry Pis. But honestly, that kind of looks the same as doing it anywhere else right now. So
I don't think I've got any questions, but I would definitely ask that anybody who's interested in this, yeah, let us know.
yeah,
This is something that, yeah, both Buoyant and SUSE are pushing on. So feedback would be amazing. I'm gonna give it. Yeah, my normal product manager pitch, right? Help us help you.
if you like this, please help us help you. That would be wonderful. I'm going to take a moment and find the name of the security thing as well. There we go. Cloud Native Security Con North America 2024.
Nice.
Let's put a link to that in the chat.
Yeah, I guess general question that I can imagine people having. What's next, right? Do we know what's in the pipeline for this functionality going forward?
What
And
can
not to
we
put you
say
on the
about
spot.
functionality? Well, I know I'm thinking about what we can say. Okay, things that, so the next Service Mesh Academy is IPv6. I am not sure if this works yet with IPv6, so that's an obvious thing of making sure it does work with IPv6. I actually, with this, we are at the point where there are two things that I personally want to do now that we've gotten to the place where we have an easy way and we have an auto registration controller. One of them is I want to go ahead and properly configure a reasonable way of using Spire rather than the horrible demo hackery that we have right now. And I want to work as well to sort out some of the best practices for, suppose you are running this on bare metal, right? What's the best way to do that? I have learned an enormous number of things about things that are not the best way to do that. I can tell
Same.
you
Yeah.
lots and lots of ways that are not good when you're running on bare metal. But I do want to put together some things about what are the best practices, right? And those are the two biggest things for me personally coming onto this. There's also, I mean, there's a lot of stuff with integrating it in with other Linkerd features and sorting out a bunch of stuff like, you know, what's a good one? Multi-cluster plus external workloads would be
Right.
really pretty cool. And
Yeah. And that's
I'm
something that
I'm
I
kind of I'm kind of optimistic that it would probably work,
think it
but
should just work. It should just
haven't
go.
actually tried it. Right? Yeah.
Yeah, I think kind of on my side, I'll pitch that I'm looking to integrate this in with a project called Ocre, so that way you can have a lot of this be assuming you have a way to provide that probably hardware root of trust, or
Yeah.
some way to have a root of trust already built in that is tamper proof of some level. Um, yeah, be able to have a machine register against like the local cluster, let the cluster know it's there, and then open up a way that the cluster can say, hey, here's how you configure the service mesh extension and then start the workload that you need.
Yep.
Probably using a project called Ocre, which I will drop a link to in the chat as well. This
That'd
is
be
a
cool.
CNCF project.
We actually had a question about, so, joined in the middle, can we go back over some of the valid use case stuff? And in fact, that's a nice segue into that one,
Yeah,
because one of the use cases that Andrew has mentioned in passing to me is, suppose you've got a factory floor with lots and lots of little devices or robots or whatever. And that also gets interesting when you're talking about things like Acri, because you can be talking about,
or HMI devices, right? Or human
yeah,
machine interface, right? Wall boards, kiosks,
right.
touchscreens,
It gets kind of
things
interesting
like
because
that.
you
Yeah,
can, when you're talking about things like that, you can also be talking about large numbers of devices, and you could be talking about devices where it's hard to just walk up to the device and mess with it. And so there are some really interesting provisioning and maintenance challenges going on with those things. Um, Kenneth, high level idea, extend the service mesh outside the cluster by installing Linkerd inspired directly on Linux, probably, or Docker Podman to handle transport and identity respectively. Yes, that is
that's the basic
exactly right.
idea. Yeah,
Yeah.
yeah,
And we have, so for example, I've done demos where you have a Raspberry Pi and pretty much everything is running in a single Podman container, just because one of the things that I have found about the wrong way to do this one is that if you have the Linkerd proxy do its IP tables thing on the bare metal, you suddenly can't talk to very many things. Like, in particular, I saw DNS start to fail and things like that because it was trying to route it through the proxy, which wasn't working. So some way of isolating some of these to your workload is good. But to Andrew's point, hey, Podman lets us do multiple pods, and we can, we don't have to limit ourselves to piling everything into the one container. And so a thing that I want to do is come up with more of a best practice thing where we can say, oh, here, we have built this thing that you can use to bootstrap, in a pod, and then you run your workload outside it in another pod or something like that. Just
one of the
because,
other things that I want to explore
yeah,
is running virtual machines and
yeah,
having the traffic from those VMs be routed as well and give basically the whole VM an identity. That way
yeah.
you can run more legacy workloads, for lack of a
Hmm.
better term, or just workloads that you don't have access to rebuild.
Yeah, exactly. There's a lot of, I mean, the VM case is very similar to running it on a Raspberry Pi or running it on, on Metal, right? It's just your Metal is virtualized. So yeah, there are a lot of interesting questions about best practices there, and I would like to go ahead and show people some samples there, right? I think I'm going to drop the screen share because I don't really see a
Yeah.
lot of value in that right now.
Another question. So I'm going to take these in the opposite order, but does Linkerd Proxys use the Linux T proxy like Istio does, which would be like, yeah, tunneling network adapters effectively?
It
Not that I'm aware of.
The way it actually works under the hood, and you can see this in the Service Mesh Academy where we're doing this the hard way. Um, it starts the proxy running and then brutalizes IP tables to say, take all the traffic except for things on these specific ports and hand it to the proxy. So it's a pretty low level sort of thing. The flip side of that one is that it doesn't really rely on a lot. It just relies on IP tables. It can work with NFS tables as well, but it relies only on the Linux packet filter. Is probably the most correct way to say that.
The last question is Linkerd on the external node call home? Like, is there a way that the ingress gateway on the cluster's edge?
So right now, that's why I say we rely on direct IP connectivity. The harness talks directly to the auto registration controller in the control plane in the cluster.
Yeah, to not, you
I
would
have
have to
not
use WireGuard
actually, yeah, I
or
have not
something along those
actually.
lines.
There are a bunch of things that I am interested in toying with, but right now you rely on direct IP to connectivity. One of the other things in the future that I did not mention is people have asked about trying to arrange it so that we can, so that we can operate without direct connectivity, the way we do with multi-cluster going through gateways. So I know that that's being discussed, but it's not something that we've done yet.
I
Because getting it to this
shortlisted,
point was hard enough, really.
right? A project that's on my short list is potentially looking at like Headscale, which is the self-hosted Tailscale, basically, and putting Headscale inside of the Kubernetes cluster as well, and so that way you could have a little bit more, basically an easy way to get a VPN and have that direct IP
Yeah,
addressing at least.
yeah.
Does it solve
Andrew and
all
I
the
were
problems?
talking
Probably
about
not, but
setting that up for this SMA, but sadly,
just
reality intruded.
yeah.
It's there's been a lot of stuff going on over the last month or two. All right. Anything else come to mind? Okay. Well, let me then. Oh, I guess I do have a reason for this. So yeah, you can reach me at Flynn@Buoyant.io or as at Flynn on the Linkerd Slack and really basically all the Slacks. Andrew, you are on the Linkerd Slack as well as Andrew Gracie.
Yes.
And with that said, next month, IPv6. People have been asking about this for a while. It's finally here. I'm simultaneously really looking forward to this one and looking at it and going, oh God, I have to figure out how to use kind. Mostly I'm looking forward to it because, it's not like we ran out of IPv4 addresses 5 years ago or anything like that. Yeah. So yeah, I'm looking forward to this one. It should be good. Okay. And
Quick question on that. Is that pure IPv6 or is that IPv6 or is that dual stack?
both.
Sweet.
Yeah. We can't, as a practical matter, pure IPv6 is a little less useful in many places than dual stack is. So there are a lot of people out there where dual stack is the thing that'll really permit them to get things moving. A lot of people seem to be operating on the idea that they'll switch to dual stack and then start aggressively getting rid of IPv4 and then end up being v6 only. And on the whole, I think that's a good way to approach it. My on the whole is tempered by the fact that IPv6 has been around for 28 years, and
There's no real incentive.
Yeah, we've come up with such effective tricks for extending the life of IPv4 that it's made it really, really hard to migrate off of, you know? So,
Uh, The timing is actually really nice because we were having a very similar conversation internally here at SUSE, and
what, you mean people are
the
finally getting sick of NAT being everywhere and, you know,
well, and I think especially for like industrial IoT, I mean, we're seeing that you want
huge problem.
more. Yeah, you need more devices, or sorry, you need
Mhm.
more addresses for those devices so that they all have
Yeah.
identity. Back to the Spiffy and Spire problem, right?
Mhm. And you run across problems where, you know, the usual way that people approached that was always, "Oh, it's cool. We'll just grab an RFC 1918/16 and everything will be great." And that only gets you so far. Um, so yeah, I have opinions about IPv6. It makes me very, very angry that my ISP at home won't route V6 to me still. But but yeah, I've run dual stack at home for a little while.
Nice.
And I'm really looking forward to being able to do that with Linkerd. So
Nice.
other things we mentioned, this particular SMA required you to use Bell Buoyant Enterprise for Linkerd. The auto registration harness is a Bell feature. It is not a Linkerd open source feature. This is one of the several things that Bell can do that are really extremely cool. Check it out, please. That would be a good thing. And I think well, last chance. Anybody have any other questions,
Let's see, Judith
comments,
typing.
heckling?
Oh, I can tackle. Do you want tackling?
I don't know. Do you
Was
have
that
any?
was that meta heckling?
Going once, going twice. All right. Well, like I said, sources should be up. The sources, I believe, are up to date. Oh, wait, we got one more thing. Can Linkerd escape the limitations of IP addressing?
Nothing can escape the limitations of IP.
Yeah, but all right. So I'm not going to commit to this because I don't yet know enough about our V6 implementation. But it's at least theoretically possible to me that you could allow Linkerd to be running V6 internally, and if you're doing multi-cluster, to use V4 as the transit to the other cluster. Um, and Kenneth's second comment there about strong crypto identity instead of an IP address, we already strongly recommend that you never ever use IP addresses as proxies for identity. So whether you're on V4 or V6, that recommendation does not change. There are
Yeah, and I think
there are too
using
many ways you can spoof IP addresses to cause mayhem.
I think I
Many
think
of them can be caught, but not all of them.
yeah, and I think the better solution would actually be maybe some using was it 802.11x that gives you identity um it, and then tying that in with a hardware root of trust so that way you have a
Maybe
strong cryptographic. Again, I don't know that this has been. I
I'm
remember working on this problem 10 to 15 years ago, but
yeah.
the market really didn't take it, so we stopped,
Well,
right? It wasn't a big enough problem at that point.
well, fundamentally, security is always at odds with convenience,
Oh
and
yeah.
absent some really clear demonstrations of value prop, convenience tends to win, which is very unfortunate. One thing that I wonder about 802.11x is actually, uh, and sorry, I should be more careful on how I phrase this one. I do not know a lot about 802.11x. I just kind of vaguely remember it from back when, right? But I honestly kind of wonder whether if you have a hardware TPM or something like it, I wonder if 11x really gains you a lot more if you're already not trusting the IP address. If you're just viewing the IP address as a short-term way to carry packets around and the encryption identity of the packets is actually the important thing. So kind of makes me wonder.
Oh, and it's 802.1x.
802.1x.
11x
Okay.
is Wi-Fi.
Oh yeah, 11x would be really interesting,
I
wouldn't it?
I said that and I realized I was like, wait, hold on. It's very
11x
much
would
the
probably be something like wireless using X-rays or something like that. That sounds kind of disturbing.
that's
All
basically
right. Well,
millimeter
I think we're
wave.
going to go ahead and wrap it up. Thanks everybody for sticking around. Really appreciate it. If you have further questions, Flynn at buoyant.io. Actually, you know what? Let me put that up for just a minute. Flynn at buoyant.io or andrew.gracie at susa.com. And it depresses me that I almost always try to type susa.io first. Yeah. So there are our email addresses. If you have further questions, always happy to take them there or to be found on Slack. And other than that, thanks much, Andrew. Appreciate it. And we
Thank you.
will be back. Well, I at least will be back in a month for IPv6. And I'm sure we'll drag Andrew back on to talk about best practices for mesh expansion on bare metal. That'll be kind of fun.
Better for that. That
Have
means
a
I
good
need
one.
to
Thanks
learn
all.
them.
Say again?
That means I need to learn them.
Well, yeah. It's okay. We'll work together and make something up.
Right.
It'll be fine. All right.